everybody. Thank you for joining us today for Skype a Scientist Live. This is Neuroscience Week. We've partnered with the Philadelphia chapter for the Society for Neuroscience for a week full of brain content. We're super excited about that. Today, we're joined by Dr. Sara Ward, and we're going to be talking about her work and any questions that you all have about the brain. So before we get started, just a reminder that Thursday nights, every Thursday, this is particularly for the adults in the audience, we run a trivia night every Thursday at 8 p.m. Eastern, and the ticket sales from that, it's $5 a person, go to supporting a grant that we're currently building for underrepresented science communicators. We want to make sure that we're supporting their work, and we like to see all the cool stuff that they produce, and we'd like to support that. So we're slowly over time building that. So if you think that sounds fun, you can check that out. Skype a Scientist After Hours Trivia. Also, we have another session coming up on neuroscience as well. That is going to be on Friday, also at 1 p.m. And with that, I'm going to hand it over to Sara so she can introduce herself, say who she is, what she does, and why she likes it, and then give us a brief little introduction on her work.
Awesome. Thank you so much. I'm really excited to do this today. I am a scientist and professor at Temple University Lewis Katz School of Medicine. I've been a scientist for 20 years, and in that 20 years, I've also spent a lot of time talking to people like you about research, kids, adults in the community, so I'm really excited to be here and share with you a little bit about what my job is like. So I'm going to just share a few slides with you for an introduction, and then we can move on to the really fun part, which is the question and answer part. So this is a picture of me in my laboratory at Temple University, and this is a picture of the outside of the building that I have not seen very much in the last 8 months. Right now I'm working from home while the investigative team that I coordinate is in the research laboratory. So a little bit about what I do at work. As I mentioned, I'm a scientist and a professor. So my job is really split between running a research laboratory and teaching. So for my work in my laboratory, I run a behavioral pharmacology laboratory. We study the effects of different kinds of drugs on animal behavior. So in my everyday work, I plan scientific experiments. I write a lot of papers. I used to spend a lot of time traveling to meetings to present my research and to network with other scientists. And the best part about being in the laboratory is to train future scientists who want to do what I do. As far as teaching, I teach medical students at Temple and graduate students, as well as undergraduate students. And as I mentioned, really one of my absolute favorite parts of my career is going to schools and talking to students, anywhere from kindergartners all the way up to high school students. So just wanted to share with you sort of a list of my favorite things that I love about my job. Number one is teaching. I absolutely love teaching all grades. It's so exciting and fulfilling. As I've already mentioned, I also get to travel a lot. This is a picture of my mom and I in northern Italy. I got to take my mom along with me to a scientific conference that I was presenting at. So I've been all over the world sharing the kind of research that I do, which is really fun. Sometimes I get to talk to the media. This is an interview that I did with CNN for a series that they were doing on medical marijuana. I also have a lot of fun outside the laboratory with the folks in the lab as well. And really, most importantly, I get to help people understand how the brain works. And this really leads to why I chose my career path. So when I was a kid, I was really interested about feelings and emotions, and I still am. And I was interested in what made some people feel different from other people. Why did some people get sad or depressed? I was also very interested in drug addiction and why some people used drugs and had a hard time stopping using drugs. So I really wanted to understand how the brain works, what happens with the brain when we sometimes don't feel the way we think we should feel. And I wanted to help people to understand and respect the brain and things that can happen with the brain that affect the way we feel, like people study the heart or the kidneys or other parts of the body. And so, just a very brief rundown of my career path. It was really in middle school and high school that I fell in love with science as well as with the study of psychology. And I really wanted to tie those two things together. How does the brain control how we feel and how we behave? So I majored in psychology in college. And then after college, I worked for a few years at a company that helped to come up with new medicines to help the way our brain works and help the way we feel. After working for that company for a few years, I decided to go to school for even longer. So I went back to graduate school for 4 years, and I got my PhD in neuroscience. And then I spent a few years after getting my PhD training in other people's laboratories and how to do the kinds of research that I was interested in. And then in the past 10 years, I became an assistant professor of pharmacology at Temple University. And so, as I mentioned, in my laboratory, what we really study is animals. And I started doing this as a student in college. And I use animals to study how the brain works. And two of the main areas of research that I do are drug addiction. How do people become addicted to drugs? What changes happen in the brain? What can we do to help people with substance abuse problems? And I also study pain, because the drugs that a lot of people use to treat pain can also become drugs that people abuse and become addicted to. So I try to study new drugs for the treatment of pain, make sure that those drugs don't produce drug addiction or drug use problems, as well as studying more about drug use and drug addiction and how we can come up with ways to try to help people that are suffering from drug abuse. So that's just a brief introduction about my job and how I got to be where I am today. So now I will turn it over to all of you for our question and answer session.
Awesome. Thank you for sharing that. That's super cool. I think one thing that you highlighted that I definitely didn't know when I was younger, before I became a scientist, is how much travel we get to do. Like, you hear about like the field scientists who go to wherever their field site happens to be, whether it's, Oklahoma or Hawaii or wherever. But you don't know how much travel we do just to share our work with fellow scientists. And that is definitely a huge job perk. I never really traveled when I was in high school because we didn't have the money to go places other than the Jersey Shore. But yeah, once I started being a scientist, it was wild. It was great. It was super awesome. Okay, so we have lots of questions here. So one question is, here's interesting. Okay, so we have the drugs that we use for us, and that can be like pharmaceutical drugs, like drugs to treat us. And then we also, when we go to the vet, we give our animals drugs. Do you know, like, how do we know what's going to work on both of us and what's only going to work on a person or only a dog or anything like that?
Yeah, so a lot of the research starts, all of the research on developing medicines starts in animals. Or even before animals, starting in more simple things like just studying cells. But we always study the effects of drugs on animals before we give them to people. And a lot of the medications that we're trying to develop for people are also drugs that could be really helpful for companion animals. So, there are some pharmaceutical companies have separate programs. I know, like Bayer and Bristol Myers Squibb, they have sort of a veterinary branch, but for the most part, the development of the drugs is very similar, especially for any diseases that are the same. One of the reasons why we use animals is because almost every biological process that can go wrong in people can go wrong in animals. And for the most part, most of what will help us for medicine will also help animals. So it's really, for the most part, the same kind of thing. Couple of the differences just being how much of the drug, because animals are mostly smaller than people, although animals can react to some drugs differently. So, figure out the right doses. But, that's really it's really, for the most part, the same pathway.
Cool. We have a question from Gavin and Gwyneth. Where did you go to undergrad, and then where did you go to graduate school?
So I went to undergraduate at the University of Connecticut. I grew up in Stafford Springs, Connecticut, and I went to college 15 miles down the road from my parents. So I went home every weekend and did my laundry and ate my mom's good home cooking. And then I worked after undergraduate at a company in Connecticut. So when I decided to go to graduate school, like you, I rarely traveled growing up. So I wanted to get out of New England for graduate school. So I got my PhD in North Carolina at Wake Forest University, and absolutely loved the time that I spent in North Carolina. It's a really beautiful state. And then, sort of as a compromise, I moved halfway back up to Pennsylvania. So I'm about 4.5 hours from Connecticut in my family.
That's funny. I went to UConn for grad school and grew up in Philadelphia. So one of the reasons I was really excited that there was a squid biologist at UConn is I was like, oh, I can actually drive home. This is perfect.
Yep.
Awesome. Victory, age 7, wants to know, why do we get sad?
Yeah, so I was just teaching a lecture about this morning to the graduate students at Temple, and most of the lecture focused on emotions and why do we feel emotions. One of the most important reasons to feel emotions is so that we can learn how to behave and interact with other people. So it's very important for us to learn what makes us sad. Did something that I did or said to somebody make me feel sad? Did getting a bad grade on a test make me feel sad? And that's a way to tell myself, well, maybe I should change my behavior. It's also important for other people to know when they've made us sad. So, that's a reason why we cry or we look sad, so that other people can know that and so that they can learn how to interact with us. So it's actually very important to be able to feel all of these emotions, and hopefully we can learn through experiencing those emotions how best to get along with everybody and how best to make decisions. And then the real problem comes if we have sadness that we can't manage, or if we have sadness that is more than it should be for a particular situation. And that's when we really want to understand, what is going on in the brain if you are feeling too sad, or if you can't, manage that sadness in a healthy way.
Yeah. And a lot of people are feeling too much sad this year because it's been a pretty brutal year.
Yep.
So yeah, it's pretty common this year. The next question is from Wintana. How many years of education total did it take you to get to the point where you had your PhD?
So I used to know this off the top of my head. So 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. So 21 years of school, from kindergarten to the end of graduate school. And then, as I mentioned, after graduate school, you're still sort of in training. I finished graduate school by the time I was 30. So I was officially not a student anymore when I was 30 years old. And then I had a little bit extra time of training after that before, some of my friends when I was in my 20s and even my 30s would ask me when I was going to get my real job. But the lucky thing for me is that I still love school. I'm home. My kids are home right now. I have a 10-year-old and a 12-year-old, and normally they're sitting next to me on the couch doing their schoolwork. And I love it. I still like doing algebra and learning science and grammar. So I was really lucky that I love school and I love my job so much.
That's great. Yeah, I was also 30 when I got my PhD. So it takes about that long
Yeah.
for almost everybody.
Yep.
Here's an interesting question, also from Wintana. Why are some people more emotional than others?
Yeah, that's a great question. So we all have the same parts of the brain, and we all feel the same things in the same places, but we definitely all feel things differently, and a lot of that just really has to do with the sort of tools that we were born with. So when we are born, we get some sort of instructions from our mother and some instructions from our father, and all of those instructions on how to make us get combined. And some of them are, like I said, always the same. We have two eyes, we have a nose, we have a mouth, we have a brain. I have a part of the brain that makes me feel happy. But there are little differences between all of us that we're born with. And then on top of that, we all have some different life experiences, right? For most of us, we live in a house, we live with family members, they go to work, we go to school, but there are some differences. Not all of us live in the same parts of the country, have the same number of family members around us, our schools aren't all the same. So it's really a combination of the instructions that we're born with that have little bits of differences, and then our experiences that we have growing up and how those all combine to make us all unique.
Awesome. Great answer. The next question is from Vanessa. In your research, have you seen any long-term benefits of cannabinoid use in relation to improving depression and anxiety? And can you also tell us what a oh my gosh, I know how to say that word, but my mouth currently can't do it. Cannabinoid. What that means?
Yeah. Yeah, so I would say most of the research that I do in the laboratory right now is studying the chemicals in cannabis or marijuana. And those chemicals are called cannabinoids. And, as someone who studies pain and drug abuse, I'm very interested in cannabis or marijuana. What are the potential harmful effects of using cannabis, and what are the potential beneficial effects? So people have been using cannabis or marijuana for thousands of years, both as a recreational drug, like some grown-ups use alcohol, and as a medicine. And one of the things that people report is using cannabis for anxiety and depression to make them feel better. One of the frustrating things in this area, as far as trying to understand how cannabis can make people feel better, is that most of the research over the past many, many years has focused on what can cannabis do that's bad. So we're a little bit behind in our research of understanding what cannabis can do to make us feel better. And because cannabis can make people feel very different, have very, big effects on behaviors and feelings, and because some people can sort of abuse it, get addicted to it, we're trying to understand, is there a safe way to use it to make people feel better that doesn't impact how well they get on in their jobs, doesn't impact how they can drive, how well they can learn things. So when we study it in animals, there are a lot of different chemicals in cannabis. There are over 100 different cannabinoids in cannabis. There's one in particular that I study in the laboratory, and that's called cannabidiol, or CBD. And CBD has been sort of really exploding in knowledge in the general public. People can now walk into their grocery store and find this chemical on the shelves. The reason why people are really excited about CBD is that it is not the chemical in cannabis that gets people high, that can make people feel really funny, maybe affect whether or not they should drive or go to work. But it does seem to be able to decrease anxiety. And that's one of the number one reasons why people say they use CBD. Again, the research is a little behind. So mostly what we know is what people who use it tell us. There have been some studies in people, very, very small studies, that have shown that in people who are anxious, that CBD really can make people feel less anxious. And in laboratory animals, we have ways of testing that. So, one of the most common things we do to test rats' anxiety level is we put them on it's called an elevated plus maze. It looks like this. And so you can picture a stand with two arms. One of the arms is enclosed and in the dark, and the other arm is like a plank in the open that the rats can walk along, but it's bright and there's no barriers. So if a rat gets anxious, they spend more time in the dark with the walls. And when they're feeling relaxed and like they want to go out and explore, they spend more time out in the open. And so we can give CBD to rats and actually see that they will spend more time going out and exploring. So those are the kinds of experiments that we do in the animals. And we know that this drug or chemical in cannabis called CBD definitely alleviates anxiety in rats. And a lot of people feel that it does that for them as well.
Is there any work in cats? Because I have a very anxious cat at home.
Yeah, so interestingly, Cornell research labs, going back to the question about medications for people and medications for animals, because so much animal research has been done with cannabis and cannabinoids, Cornell labs at Cornell University, which is a huge veterinarian college, they've run a lot of studies to see if the effects that I see in rats happen in cats and dogs. And they have found that drugs like CBD decrease anxiety in pets. They've figured out the doses that they would recommend for that. And so as a cannabis researcher, when I travel to meetings, people give me products. Now, cannabis is an illegal drug, so I don't take those products home with me. But sometimes people will just give me CBD products, and CBD products are legal now to sell, that one chemical from the plant. And someone gave me bacon-flavored CBD to bring home to try on my cat, who is also extremely anxious. Now, my cat is so anxious that I can't get near her with bacon-flavored CBD. But there are animal-specific products that are on the market. Again, how many of those have been actually tested? I can't recommend them to you, but I can tell you that Cornell Laboratories has done studies in companion animals for anxiety with cannabinoids.
That's super cool. Thanks.
Yeah.
Let's see. So Cameron, age 9, wants to know, why do some people have a higher pain tolerance than others? And does that have anything to do with their emotions in the brain?
Yes, absolutely. That's such a good question. So a couple weeks ago, I was teaching my college students about pain. And, one of the really interesting things about pain, which again reminds me of the question about sadness, is why do we feel pain? Well, we have to feel pain. There is a condition that some people are born with called chronic insensitivity to pain, and they can't feel any pain. And you might think, oh, well, that is great. I wish I had that. It's actually extremely dangerous, because if you can't feel pain, just like if you couldn't feel sadness, it hurts your ability to make good decisions. We feel pain so that we can protect ourselves and not do things that are dangerous for our bodies. And so that's why pain hurts and makes us feel bad. Again, unfortunately, it's not enough to just say, oh, don't do that. It comes with that painful sensation and the painful emotions. So our body's designed to feel it, detect it. Or if I put my hand on something really hot, it sends a message to my brain, oh, that was hot. Sends a message to my brain to lift my hand up. It also sends a message to different parts of my brain to make me upset. There's actually 2 different signals that come up to the brain. One to say, that was pain, don't touch it. and the other one to say, oh, that hurt, that felt terrible, and make me upset. And for people who don't respond as much to pain, there's probably two different differences. Some people just don't detect the pain as readily, but probably the bigger difference with some people is the emotional part, that they don't care as much. And that's more of what we are aware of. We're not as aware of how sensitive we are to the feeling of hot feeling,
Right.
but we're more aware of our emotional feeling of how we feel about it. Women in general are less, they are more tolerant to pain. So women have a higher pain threshold than men, and different things can affect it. How I feel about a situation, the mood that I'm in, my past experiences with pain. There are many, many different things that can impact how I process pain, how that pain makes me feel, and how much emotional attachment I put on it.
That's super cool. So kind of related to that question, Erica wants to know, the website said that you study neuropathic pain and neuroprotection, but what is neuroprotection?
Yeah, so neuroprotection means things that protect our brain cells from dying. And, you know, a lot of the different diseases of the brain that people are interested in have to do with that. So some of the diseases that maybe you're familiar with are things like Alzheimer's disease, where elderly people can start having memory problems. Parkinson's disease, where some people have movement problems. So a lot of those kinds of diseases are when certain kinds of brain cells in the brain start to die when they shouldn't be. And there are different reasons why that might be happening. So studying neuroprotection is understanding what are the different things that hurt brain cells and make them start to die, and what are the different things that we can do to try to prevent that from happening. And actually with cannabis and with cannabinoids, one of the things that we study in the laboratory is how much cannabis can decrease inflammation that happens in the brain and sort of stop our own immune system from getting overly active and producing too much inflammation. It's actually, I can use the example of COVID-19 right now. So when some people get COVID-19, they get a lot of virus in the body, and the body gets very upset and concerned about that. And the body increases its own immune system to attack the virus, which is nice of the immune system to do that. But when the immune system does that, the chemicals that it releases can not only be bad for the virus, but bad for us. And so there's two different things to worry about with COVID-19. How can we try to treat the virus? And how can we also try to protect ourselves from our overactive immune system that's getting worked up about it? So the same thing happens in the brain. If there is something going wrong in the brain, I have an infection in my brain, or I have a brain injury, I got hurt, bumped on the head, or with these things like Alzheimer's disease, our immune system kicks in and tries to help. And when it does that and does it, too extra, that can start to hurt our brain cells too. And one thing that cannabis does that people and doctors and researchers are really excited about is that cannabis seems to be able to tame that down a little bit. And people are, people are not only studying cannabis to try to help protect the brain from different things that hurt brain cells, but people are also now researching cannabis for COVID-19. I did a panel last month, similar to this, like just a group discussion with other scientists about cannabis and COVID-19. And there's research sort of coming out every week looking at whether or not cannabis itself or some of the specific chemicals in it might either help to attack the virus or help to sort of protect ourselves from our immune response to it.
Wow, that's super cool. I know when I was taking immunology as an undergrad, my professor said that the immune system at any given time is walking a tightrope between killing us and letting everything else kill us. So it's like, it's very, I'm glad that I am personally not in charge of any immune systems, because it seems like a very delicate process.
Yeah. And it goes back to what we were saying about sadness and about pain, right? We've evolved these things to protect us. And, you know, way back a million years ago, probably the most important thing for the immune system to do was to fight, you know, as much as it could, when people didn't live very long compared to now, and the problems that they faced were probably huge. Right. Now that we live longer, we're healthier, I think the immune system hasn't caught up, and it still shows up just like raring to go. Right. And we're not that good yet at turning it off, you know, at a point where it's done. Thank you. Go home now.
Right. It's awesome. So we have a question here from Sebastian. Why is it so hard for a frequent user of drugs to stop using drugs?
Yep. I mean, that is such an important question. I think it's important to talk about. I think it's important to understand that that is the reality for people who have drug abuse problems, because for the most part, people know when they should stop. They know when using drugs is having very bad effects on their lives. And there's a few reasons why we think stopping is so difficult. So one of the things that happens if we put any kind of drug into our body, and we do it often, our body starts to get suspicious and worried. And our body will actually start to try to resist that drug from doing its job. Mm-hmm. And so if you take the brain and drugs that people might be using, the brain will be like, whoa, I'm not really sure that all this drug is supposed to be here all the time. So I'm going to change the way I can respond to it. Mm-hmm. And the person then starts to have to use more drugs to feel the same way from the drugs. So the brain cells are starting to resist, and it becomes harder for the drug to do what it's going to do to that cell. Mm-hmm. So the person starts to use more drugs. The brain keeps getting more and more concerned and changing and changing and changing. So now you have a person who's using a lot of drugs on a brain that's now really, really different than the way it used to be before the person used drugs.
Right.
All right, person wakes up one morning, I am not going to use those drugs anymore. So they don't use the drugs, and their brain is left behind all changed. And now that brain changed because it was used to the drugs being around. Drugs go away, brain is like, now I've made all these changes, but it doesn't work anymore. Right. Because that drug is gone. And so the brain really feels the effects of having made all these changes, and then the drug is taken away. And that what the person feels is something we call withdrawal. And it's super crappy. And for different drugs, they make people feel really sick in different ways when they're going through this withdrawal period. So that's one of the reasons why it's really difficult. And for some drugs like alcohol, it's also extremely dangerous. If someone has been using alcohol for a very long time in a very high amount, they can actually die when they stop taking alcohol and need to really go to a doctor and be in a hospital when they stop. So, you know, it's not only just sort of feeling crappy, it can be really, really physically dangerous. So that gives you an idea of how much using these drugs is changing your brain, to the point at which if you stop taking it, your brain can stop working properly and stop being able to keep you alive. So that's one of the reasons, and then the other reasons really have to do with, again, changing your emotional responses as well. And really depending now, if you think about the same kind of thing, but my feelings, my brain now gets used to feeling normal with these drugs there. Right. Drugs go away, and that is then really replaced with a lot of depressed feelings, anxious feelings, really, really, really upsetting feelings that the person wants to go away. They want those feelings to stop. And it's really difficult to get through that. And that period of time for different drug users can be really long, from days to weeks to months.
Yeah, that's really hard. Awesome. Well, thank you for answering that tough question. We've got another tough question for you, this time related to animal research. So Evan has asked 2 questions. One of them is, will we ever be able to test drugs without testing them on animals? And generally speaking, how do you grapple with using animals in research?
Yeah. Yep. Fantastic questions. And really, this is one of the reasons why I like to talk about my job to kids, because I was a kid once. And I cried in 6th grade biology class when my teacher dissected our parakeet that we had in class and died. And I ran out of the room in tears and was absolutely horrified. How could somebody do something like that? I never wanted to cut open an animal. I thought about becoming a veterinarian, but I said, nope, I could never, ever do that.
Right.
Then as, my interest grew in understanding the brain and wanting to help people who suffered from brain diseases, it really becomes a question of priorities and what can we do? If we want to have medications right now that are safe for people, the only way right now we have to do that is testing them in animals. And, with certain kinds of research, it's not as challenging to worry about. But other kinds of research, I am a pain researcher, and to study pain, we need to use animal models of pain, and it does become difficult. So it is a balance, and I think if you're doing this job and you don't think about it and you're not concerned about it, then you're the wrong person for the job. Something that we always need to think about. The alternatives right now are not discovering any new drugs. Or I've heard people say, well, why don't we test it on people? Or why don't we test it on people in prisons? That's a conversation for everybody to have with themselves. But for me, I think it's appropriate right now to use rats and mice for the kind of research that I do. As far as not needing animals, we only know so much right now about the brain. There are certain things like, take the skin. We can grow skin cells in a laboratory, in a dish, and basically sort of like have skin that's not attached to an animal with feelings and emotions, and we can test different things. That's wonderful. Other things are a little bit easier to understand, but not completely, like how the kidney works, how the liver works. We barely understand how the brain works. So in order to get to a point where I could sort of design a computer program that works like a brain, and then I could try to see and test, well, what if I did this? Would that change that? There's just so much more we need to understand in general about how the brain works when it's healthy, to really be able to replace animals in research for coming up with medications. But I think it's a great question, and everybody should feel very open about having those kinds of conversations with their family and friends and people like me in their community.
Yeah, that's a great answer. Thank you. We've got the next question is from Dexter, age 8, and Milo, age 9. What exactly is the difference between sadness and depression?
Mm-hmm. Yeah, no, again, I think a really important question. So, as I mentioned, most of us don't enjoy feeling sad. Every once in a while, I sort of, get a kick out of feeling a little bit bad for myself. But for the most part, we don't want to feel sad, right? But we have to. It is important. If somebody is mean to you, it is important to respond to that in the right way. So sadness is necessary, and we aren't overly worried about it when you are sad for reasons that should make you sad. The first time I had a pet die, that was devastating. I can remember that day. That's normal. So somebody being really mean to you at school, that's normal. Waking up in the morning feeling sad that you can't connect to anything that really happened and that you can't get over by going and doing something to cheer you up. That's when we think about something being more like depression than sadness. So, the things that doctors look for is, are you feeling sad all the time when there was nothing that happened that should have made you sad? And is that sadness preventing you from moving on? So when my son gets really sad about something, he loses a game on the computer, and I say, how about a bowl of ice cream? He's up and over it pretty quickly for the most part. Right. But if you're feeling down and nothing like that, going and playing a game, going and playing sports, eating your favorite food, getting, treated to something by your mom or dad, when that doesn't help, that's also a sign that it's something more serious than just the sadness that we feel from time to time.
Awesome. Thank you for answering that. Okay, so we try to keep these sessions at 45 minutes, and we are right about there. So thank you so much for answering all of our questions today. Folks at home, I know there were a lot of questions that we didn't have time to get to today because you were all so wonderfully curious today. So please tune in Friday at 1 p.m. Because we'll have another neuroscientist on, and you can ask questions of him. And before we wrap up, we always ask everybody the same 2 questions at the end. The first question is, if you had the attention of everybody in the world and everybody could understand you, and you could tell them one thing related to your area of expertise, what would that be?
So that's an easy one. Be kind to people with mental illness. Be kind to people with depression, anxiety, and substance abuse disorders.
Awesome. That's wonderful advice. And then the second question is, if you still have everybody's attention in the whole world and you can tell them anything about anything, it can be as like big picture important or silly and insignificant as you like, what would that be?
Yeah, I think sort of similar. Be nice to everybody. That's our one job in the world, is to be nice people. And if you can accomplish that, you've done your job.
That's great. Compassion goes a long way. That's really great, especially in such tough times now. Like, everybody's going through something and you don't really know what they're going through. So yeah, be kind. That's great advice. Thank you. Is there anything you'd like to plug, and where can we find you on the internet?
Yeah. So, where am I on the internet? I do have a podcast every Friday about cannabis. And so if you type in how to launch an industry, you can find the link to this podcast. It's sort of like a dorky, science-y podcast where scientists talk about cannabis. And if any adults in the audience are interested in cannabis education, you can visit the Thomas Jefferson University website and find out more about their medical cannabis educational program.
Awesome. Thank you so much. So thanks for taking the time to be with us today. And Erin, thank you for signing for us as always. And just a reminder, you can join us back here on Friday, 1 p.m. Eastern, and go to skypeascientist.com to find the links for that. And also, if you want to have a conversation with a neuroscientist in your own house, in your classroom, in your scout troop, whatever you'd like, you can sign up for free at skypeascientist.com. Thank you for being with us today, and we'll see you next time.
Awesome. Thank you, everybody.
Bye. Thank you.